In this video, we're going to discuss SSS Triangle Congruence. So SSS stands for side, 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 and it tells us if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So let me show you how that works. This simulation is from GeoGebra, and the author is D. Gibson. If I compare this triangle to this open figure here, what I see is that the sides are copies. So AB is 6, A prime B prime is 6, AC is 8, A prime C prime is 8, and BC is 5, B prime C prime is 5. So let's see what happens when I take this figure and close it to form a triangle. This could be a little tricky. See if I get it here on this first try. And there we go. It's pretty close. So I have still the three sides are copies of each other. So all three corresponding sides are congruent. And let's take a look at the angles. A is 37 degrees. A prime, 37 degrees. B is 92 degrees. B prime, 92 degrees. And C is 51 degrees. C prime is 51 degrees. So we can see that when we have three pairs of corresponding sides that are congruent, we also end up with three pairs of corresponding angles that are congruent. And that is how side, side, side gives us congruent triangles. One way that we can prove side, side, side is by rigid motions. So I can translate triangle ABC along the vector AD. And what that means is I'm going to take triangle ABC and move it so that point A maps onto point D. Once I've done that, my image will look something like this. Then all I will need to do is rotate this triangle about point D so that point B maps onto point E. The completed image will look like this. At this point, it looks like a reflection across AC would map one triangle onto the other. But in order to prove that that's true, we'd have to show that the distance from B to AC is the same as the distance from D to AC. To do that, we have to remember what we learned about perpendicular bisectors. So here, BD is a perpendicular bisector to AC. And what that tells us is that AD is the same distance as CD. They are equidistant. They are the same length. That also tells us that since point B is part of this perpendicular bisector, that the distance from B to A is the same as the distance from B to C. They too are equidistant. We can use that fact to prove that AC is a perpendicular bisector to BD. We see here that AB is equal to AD, so the distance from A to B is the same as the distance from A to D. They are equidistant. On the other side, we see that CB is equal to CD. So again, the distance from C to B is the same as the distance from C to D. They are equidistant. So since points A and C are both points on side AC, and they are both equidistant from the points B, D, that makes AC a perpendicular bisector of BD by the converse of the perpendicular bisector theorem. That means that not only are these right angles, but that also means that this right here is a midpoint for BD, let's call it E, and that tells us that BE is equal to DE. So since the distance from B to E is the same as the distance from D to E, when we reflect across AC, B would map onto D, which proves that both triangles are congruent by use of rigid motions. So can we prove that these two triangles are congruent using SSS? Well, let's take a look. We see here that side DH is 12 centimeters and side FH is 12 centimeters. So DH equals FH, and they both equal 12 centimeters. We see that side DE is 20 centimeters and side FG is 20 centimeters. So DE equals FG, they equal 20 centimeters. And we see that EH is 24 centimeters and GH is 24 centimeters. So EH equals GH, and they equal 24 centimeters. So we know that triangle DEH is congruent to triangle FGH by the SSS Triangle Congruence theorem. So let's look at these examples and see if these triangles are congruent. So we see here that MP is 54 inches and QS is 54 inches. So MP is equal to QS, and they're equal to 54 inches. We also see that NP is 38 inches and RS is 38 inches. So NP equals RS, and they equal 38 inches. But if you look at MN, it's 28 inches, and RQ is 32 inches. So MN is not equal to RQ. So therefore, these two triangles are not congruent. Looking at the second example here, we see that JK is equal to JL. So JK is congruent to JL. We see that KG is equal to LG. So KG is congruent to LG. And we see that JG is equal to itself because of the reflexive property. So JG is congruent to JG. So triangle GJK is congruent to triangle GJL by the SSS Triangle Congruence theorem. So looking at these two examples, we need to now be able to use one of the theorems, SAS, ASA, or SSS, to find the value for the variable x that would make both triangles congruent. Looking at this first set, I see that triangle PQR has all three sides measure 4 inches. So it's an equilateral triangle. And I notice on this triangle that 2 of the sides measure 4 inches. So if I can make this third side measure 4 inches, then I know both triangles will be congruent by SSS. Side, side, side. So I could write the equation 3x minus 11 equals 4, and then just solve. So here I would have to add 11 to both sides. I get 3x equals 15, and when I divide by 3, I see that x equals 5. Does that work? It sure does, because 3 times 5 is 15, and 15 minus 11 is 4. Now, this second example is a little more complicated, so you really need to analyze each triangle and see what's going on. So if I look at this first triangle here, I see that angle F measures 60 degrees and angle G measures 90 degrees. They don't tell me what angle H is, but I could find that easily enough because I know that all three angles in any triangle have a sum of 180 degrees. So 90 plus 60 is 150, and 180 minus 150 is 30. So I know that angle H measures 30 degrees. Now if I look over at this triangle, I see that angle V measures 30 degrees, so it corresponds with angle H. Angle U measures 90 degrees, so it corresponds with angle G. So if I could get angle side angle, then I could make these triangles congruent. That would mean that this side here, GH, would have to equal this side here, uv. So I write my equation. 8x minus 12 equals 12. Then I solve, so I'm going to add 12 to both sides. I get 8x equals 24. Divide by 8, and I get x equals 3. Now, does that work? Yes, because 8 times 3 is 24, and 24 minus 12 is 12. But I'm not done yet, because now I need to find the value of y. So if I look, I see that angle V corresponds to angle H. They're both 30 degrees. Angle U corresponds to angle G. They're both 90 degrees. That means that angle T corresponds to angle F, which would also mean that angle T has to equal 60 degrees. So I can write my equation. 7y plus 4 equals 60. And now I just solve. Subtract 4 from both sides. I get 7y equals 56. Divide by 7, and I get y equals 8. And we could just plug it in up here to see if this works. So 7 times 8 is 56, and 56 plus 4 is 60. So T does measure 60 degrees. So I hope this video helped you to understand the SSS Triangle Congruence theorem.